Welcome to Automated Visual Software Analytics. This part is about the Halstead Metrics. In this part, we will define the Halstead Metrics and we will discuss example calculations. Let's start with a definition. The Halstead Metrics is a set of software quality metrics that quantitatively measure source code complexity. In particular, it provides two base measures. The Halstead length computes a measure for the number of distinct operators and operands used in a source code unit, and the Halstead volume, which computes a measure of the total number of used operators and operands in a source code unit. The Halstead software metrics are based on static source code analysis, and this analysis concentrates on the lexicographically complexity of source code. That means we focus on operators and operands that are defined by their relationship to each other. In general, an operator carries out an action, whereas an operand participates in such an action. The underlying assumption of Halstead is that programming requires always cognitive efforts, and these efforts can be structured in elementary cognitive steps. And now the key observation of Halstead is that the elementary cognitive steps can be quantitatively related to operators and operands. To see how this works, let's have a look on the base measurements of the Halstead metrics. The number of distinct operators and operands builds the program vocabulary, whereas the total number of used operators and operands builds the program length. This leads to two basic measurements, the Halstead length and the Halstead volume. The length is related to the distinct operators and operands, taking into account the number for distinct operators N1 and distinct operands N2, and both are weighted by the logarithm. Whereas the Halstead volume is computed by the total number of used operators and operands, N, and this is weighted by small n, the program vocabulary length. These are the two fundamental Halstead metrics which are illustrated in the following example. Here we have on the left side a C code snippet, and if we look through, we can extract operator. Note that operator has a different meaning in each programming language. In the scope of the Halstead metric, it has a meaning that an operator uses operands and denotes any kind of action. For example, here we have different operators, the star, the if or else statement, as well as blocks or other elements of the C language. These are represented as operators in the Halstead metric, and we can simply count the frequency in which these operators occur. So we have a total number of distinct operators of 10, and the total number of used operators is 18. Now let's go on to the operands. Here we have a distinct 11, and the total number is 16. Make sure that you understood that operators and operands in the Halstead metric world is different to operators and operands in, for example, C++ or Java. It's a more general definition that Halstead uses. Now let's go on to second level or higher level Halstead metrics. One of them is the program difficulty level, D. It's a measure or level for error proneness of a source code. And the assumption is that the program difficulty level is proportional to the number of distinct operators, N1, but also is proportional to the ratio between the total number of used operands and the number of distinct operands. So this is why the program difficulty level is computed this way, as a weighted product of distinct operators, used operands, and distinct operands. For example, a low level of program difficulty means that the program is less prone to errors. Based on the program difficulty level, we can build another Halstead metric, the effort to implement. It's proportional to the difficulty level, D, and the Halstead volume. Yeah, and based on the effort, we can even go further. A measure for time to implement, calculated according to the effort, but divided by 18. This is a magic number. The time to implement or understand a program is proportional to the effort. I mean, this is straightforward construction, but empirical experiments can be used always for calibrating this quantity, referring to the 18. So how many time do you actually need for 1 unit of effort? The 18 comes from early studies of Halstead and is still used today. Halstead has found that dividing the effort by 18 gives him an approximation, a reasonable approximation for the time in seconds for the projects he investigated. This time for effort factor depends on, for example, programming language, program type, and on programming conventions. But in general, it's a good value, the 18, or you can even use a more program or project specific value. But the important issue is that based on Halstead metrics, we can somehow determine effort and time to implement. There's also another important Halstead higher level metric. It's called bugs delivered. So Halstead's delivered bugs, B, is an estimate for the number of errors contained or typically inherent to a source code. The number of delivered bugs approximates this number of errors in a module. When dynamic testing is concerned, for example, the most important Halstead metric is the number of delivered bugs. As a goal, at least that many errors should be found from the module in its testing. This, once again, these values used, such as 3,000, stem from empirical studies, and it can be adapted today to, or can be calibrated today to specific settings of a given software project. Let's have an example about the calculation of these higher level Halstead metrics. For example, the Halstead length and volume, once again, for this snippet of C code. The program difficulty level can now be computed as already defined. It's 7 dot something. The effort now related to this program difficulty level and related to the volume results in 1,000 something. And time to implement, uses this time to effort factor. It's 60. And the estimated number of bugs, of course, it's a small program, so we don't have to expect many bugs here. Yeah, these numbers, if used and measured for a whole software system, give good indications about the source code complexity and about some other interesting key performance measures and indicators behind, such as effort, time and bugs. Yeah, the program difficulty level D, and this example is the basic complexity measure that indicates how difficult it is to understand or write this particular code segment. The effort to implement can be translated into actual coding time, or Halstead in its original work proposed to transform it in actual coding time. The commonly used 18 has been determined by a number of studies over the years, and the measurement for bugs is an estimate for the minimum number of errors in the implementation that should be found with automated or non-automated tests. Yeah, this illustrates how Halstead metrics can be used for source code to find these interesting measures about difficulty, effort, time, and bugs. Let's summarize this interesting and very important software complexity metric set. The Halstead metrics is a set of software quality metrics that quantitatively measure code complexity. Derived measures include program difficulty level, effort to implement, time to implement, and delivered bugs. Halstead metrics are easy to compute and can be applied to almost any program language. They are basic measures of source code complexity. Its intrinsic value is Halstead metrics are related to the cognitive effort of developers when they write, read, or modify source code. However, Halstead metrics do not explicitly consider modern programming language constructs such as classes or namespaces in object-oriented programming, though there is a minor gap to the programming languages we use today, related to especially the volume and length of the Halstead metric calculations. In software analytics, the Halstead metrics is a base measure for source code complexity and a very stable and reliable measure that is used as a basic information, a base measure used as a weight for other metrics. Yeah, this concludes this part. We have introduced some terminology. Let's summarize this terminology. Halstead metrics, once again, Halstead metrics, a set of software quality metrics that measure source code complexity by lexicographic analysis in terms of operands and operators used by an implementation, and derived measures serve to estimate program difficulty level, effort to implement, time to implement, and delivered bugs. As further reading, I can recommend this article as a way on metric of software complexity, appeared in Information Management and Engineering 2010. I will end this part with some remarks. Yeah, there's, as already said, no sharp definition of what is an operator and what is an operand. Yeah, and their definition typically depends on the programming language used. For most common programming languages, imperative programming languages, is quite easy. The code analysis function in Microsoft Visual Studio, for example, computes a kind of maintainability index, which also takes into account the Halstead volume as one factor. Yeah, Halstead metrics apply if test and maintenance efforts are to be estimated and controlled. So you can also use it as a kind of normal value, and then you can look and compare it to the actual values. Nevertheless, there are still widely differing opinions on the worth of Halstead measures, ranging from convoluted and unreliable to among the strongest measures of maintainability. In my opinion, Halstead metrics provide a very fundamental approach to measuring software complexity because it offers this relation between operators' operands and elementary cognitive steps.